Okay, so this is more of a special weird kind of video of a request video by the Justin Dunn himself. So this video is, can you pass the Harvard 1869 exam? Hopefully I got the year right. So the Harvard admission test in 1869 claimed to have around 185 out of 210 students pass this test. But if you look at the test itself, it is a brutal test. So some of the topics included in the test is math, obviously, like the three questions that I'm gonna do. Geometry, like hard geometry, like proof-based geometry. Latin, Greek philosophers, Roman battles, the whole shebang. So this is kind of old-timey, so some of the questions I'm not really sure about once, but I tried to do it the best I could. So let's get started. So the first question is more of a proof question. So prove the formula for the cosine of the sum of two angles and deduce the formulas for the sine of double of the angle and the cosine of half the angle. Oh, that was quite a tongue twister. So what they really want you to do is, I'll use blue. Prove cosine of 2a, and then I would assume by deduce just write down the formula because I don't really want to prove the other two formulas of sine of 2a, okay, a, and then cosine of a over 2. Okay, so the easiest thing you can do is write the sine of 2a and the cosine of a over 2. So what I could do is just, this is the formula for sine of 2a. So 2 sine u or sine a, people usually use u, cosine a. Actually, fix that a. There you go. And then the cosine of a over 2 is the plus minus square root of 1 plus cosine a over 2, right? So proving cosine of 2a isn't that bad. I'm not going to show you the whole proof because it takes forever. Well, but I'll show you an overview of how you should go at it, how you should get started. So there are three forms to the cosine of 3a. There is cosine squared a minus sine squared a. That's easy enough to prove because that's easy enough to prove when in a second when I tell you what you should do. 2 minus other second form is, oh, I'll use a. I'm just still using u, but it's fine. Minus 1. So what you want to do is take the cosine of a plus a, like a plus a, like back into your addition some entities. So you know that the cosine of a plus a is the cosine of a sine of a minus cosine of a sine of a. I mean, no, I used the wrong form. That's the sine version. Minus sine of a cosine of a. So usually you use x plus y, but in this instance you want to keep the a's the same. So a plus a. So it's just the cosine of a, looks like a u, but it's an a. Cosine of a minus sine a sine a. So the first one's simple enough. You just multiply the two together, so you get cosine sine a minus sine squared a. And then what you want to do is use the two Pythagorean identities to get the other two forms. So you want to know that cosine of squared a equals 1 minus sine squared a. Take that, plug it into cosine, and then you should get that proof up there. But if you use the identity sine squared a equals 1 minus cosine squared a, the Pythagorean identity, and plug it in where? There, you should get the third form, and you have proved it. So there you go. Let's move on to the next question. simple interest. Simple enough, but this question makes it a lot harder than it has to be. So, find the amount of 50 pounds, 12 shillings, and 5 pence at simple interest at 8% at the end of 5 years, 2 months, and 3 days. So, simple interest is simple enough. It's I equals P RT, where P is the principal, R is the rate, and T is the time. But the units is going to be hard because it wants 50 pounds, right, plus 12 shillings, plus 5 pence. And that's going to be a pain. So 20 shillings, if you do some nice Googling, even though those students that took the test didn't have Google, they had the next best thing back in the day, which was a tutor that taught them all this stuff. So consider ourselves lucky, guys. Equals 1 pound, so it's 240 pence in 1 pound. So 12 shillings out of 20, which is 50. And you want to convert this all in pounds, by the way. So 50 pounds plus 12 over 20, because that equals 1 pound. That's just 3 over 5 pounds plus 5 pence. So 5 over 240. If you simplify that, you get 1 over 48 pounds. So whatever you get that up to be, that is your number of pounds, your P. And this equals big P, not pounds, but principal. So the rate is simple enough, 8% or 0.08 as a decimal. But now it's the little more tricky part. So 5 years, 2 months, and 3 days, if I remember correctly. Yes, 3 days. So what you want to do is figure out how long is a month relative to a year. So that really just means go to your calculator and put 10 over 12, and you get that 0.83 repeating is your number, and that just means every month of the year is worth 0.83 years. Like every month is 0.83 years relative to 10, or simple ways like 0.083 years. That makes more sense, right? So you get 5 years here, right? So 2 months times 0.083, so 0.083 times 2 plus 3 days. And in this instance, I am using simple interest, or like the normal one. So that means I'm assuming there's 360 days a year instead of exact, which is 365. So the calculations are a lot easier because that means there's 30 days in the month for all 12 months. So I'm assuming that 3 over 30 is 0.1, and that's 0.1 of a month. So I take 0.1 and I multiply it by 0.083 repeating. So I get that 3 days is equivalent to 0.008. Oh, I'm gonna space there. Here, I'll just write all this outside. So you have 0.083 repeating times 2 plus 0.0083 repeating. And you actually get a very nice number if you add this up, which is 0.175 years. So you have your time in total is 5.175 years. So you multiply everything up, and if I got around $20.96 as my number, as your interest. You add the two numbers up, and you get, I would say, around $70.96 total. This question is not that weird. It probably just wants interest, so your interest is $20.96, or your total is 70.96 cents. Whatever, really, what they want. The question wasn't too clear. Okay, final question in this video. A man bought a watch, a chain, and a locket for $216. The watch and the locket together cost, not cost, they used cost back in the day, 3 times as much as the chain, and the chain and lock it together cost, okay, probably just a typing error of the, okay, I don't even know what they use anymore, cost half as much as the watch. What was the price of each? Okay, so really this is what you want to do is a matrix, or another way to say it is a 3 by 3 system of equations to solve this. But a matrix is probably the easiest way to solve for this, I would assume. Okay, so you know that watch plus locket plus chain equals $216. You know that watch plus locket equals 3 of the chain, and you know that chain plus locket equals 1/2 watch. But you do not want it to be in these kind of units. You want to move all your variables to one side, and on the right side just have your number, and in this case it will be 0. So you can set this up in your matrix. So how your matrix is going to look like, and you can use Gaussian elimination or your calculator to solve it. I don't really care which kind you do it. You'll get the same answer nonetheless, even though if you do Gaussian, it'll probably be better because you're actually doing it by hand and not by a calculator, which the poor chats back in 1865 I would assume did not get to have, because back in 1865 you would not see any calculators with the power to do Gaussian do systems. So, but this is how you want to set up your system. So on the left side is your W or your watch. On the right side is your with -3 is your chain, and your middle is your L, your locket. And I feel this is the hardest part, just to set up the matrix. Solving it shouldn't be too bad because you just learned that in your algebra class. And how I made this matrix is I subtracted the terms over, and yeah, so that's how you would solve that. And if you want the answer, W equals $144. I'm not exactly sure if this is right because I solved it myself, but I'm pretty sure this is right. If I'm wrong, then say it in the comments below, and give me your proof why I was wrong. So yeah, so if you can do these questions with ease, you could maybe pass the 1869 exam. But you have to remember, these aren't the only questions on the test. There are tons of geometry proof questions, Greek, Latin, so much more stuff they have to know. So they called Harvard easy to get in back in the day, but I would think it's just as hard as today. So thanks for watching this video, and see y'all next time.